All right, solving exponential equations. There's two strategies to solving exponential equations. One is to change both sides so they have the same base. And after they have the same base, you set the exponents equal to each other and solve. Okay? As an example, you go down to maybe, come on board. You can do it. Let's look at number, what? Plus 5 is 27. That's not going to work. Well, like number 8. I don't know if you can see it. It says 3 raised to the x plus 3 equals 9 raised to the x plus 1. Well, we can make 9 into 3 squared, right? So it would be 3 raised to the 2x plus 2. So you have to distribute that 2 to both terms. Set equal to x plus 3 and solve for x. Okay, so always look for that strategy first because it's easiest. If you can get the same base on both sides, just set the exponents equal to each other. Okay? If that doesn't work, what you're going to do is take the log of both sides. And you can use whatever base you want, but I would recommend using a log with a base that you could use a calculator with, so you're not having to change the base on top of everything else. So you could use natural log or just the log, base 10. Okay? So as an example, let's do this one. 16x equals 25. 16 to the x equals 25. Well, I can try and figure out what base I could get to be the same, but there's no base that's common to both. So now I'm going to take the log of both sides. Okay, and once I've got the log of both sides, this is now an exponent that can come to the front. And then just solve for x. It's not going to be an even number, so you use your calculator. But because we chose log base 10, we can just put log 25 divided by log 16, making sure when you use the calculator to end your parentheses. So if I put log 25, it automatically opens the parenthesis for me. I have to close it before I divide by log 16. So I get 1.16. Okay? Let's do another. X plus 1 raised to the x minus 4 minus 1. I'm solving for x here. So first thing I'm going to do is move the 1 over. And now I'm going to take the log of both sides. When I do that, I'm going to bring x minus 4 down. And what's log of 1? 0. So now I've got x minus 4 times the log of x plus 1 equal to 0. I'm going to distribute. So I have x. Is that what I want to do? Log of Does that help me at all? What if I made I don't know what I'm going to do here. Minus equals so if these are the same, Can I just say x is 4? Because this is the same, so x would have to be 4. What other value could x be? Just thinking about it. If x was 0 here, and 0 here, what's log of 1? 0. So it could also be 0. 0 and 4. I'm wondering how they solved this in the book. So what they did is they just used two factors. So they said, if I stop here, and treat it as two factors, this has to be 0 or this has to be 0 for the product of the two to be 0, right? So we're going to set up x minus 4 equals 0, or the log of x plus 1 equals 0. So here x equals 4, and here, how do we solve that? How do we get x out of there with the log? Well, this is base 10, right? So it's 10 to the 0 equals that. You've got to be able to go back and forth between logs and exponents. So this is 1. Subtract 1. So I found both, 0 and 4. Does that make sense? Okay, let's try another one. Let's do this one. E to the x minus e to the negative x over 3 equals 14. So I'm going to multiply by 3. What is that? 52? 42. Now what? What does e to the negative x mean? So what do I do on this side? Common denominator. What is, if I need to multiply by e to the x, what do I get? What's e to the x times e to the x? Base is the same, so what do I do to the exponents?
E to x?
Yeah. You understand that? E to the x plus x. Okay, so this becomes e to the 2x minus 1 over e to the x equals 42. So now I have e to the 2x minus 1 equals 42 e to the x. Now, I feel like I'm, yeah, on the right track. Okay, this is a strategy that we learned in pre-calculus. We might have talked about it in Algebra 2, but this is factorable if I use substitution. I'm going to let u equal e to the x. So u squared is e to the 2x. Now it's a quadratic. Okay, I can't factor it. I'm going to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2. (42 squared plus 4), square root of that, So I have 42 plus or minus 42.0476. So when I add this and divide by 2, it's 42. Should have known that. And if I subtract it, it's 0.0476 divided by 2. Right? Negative. So those are my two choices for you. It's 42 minus 42.0476 divided by 2 is negative 0.238. And 42 plus 42.0476, I don't know what I did there. Hold on. 42.04, so that doesn't make sense. Divided by 2, it's 42.0238. Okay, I'm not quite done because this is u, this is not x. So now I go back, u is equal to e to the x. So I say e to the x equals 42.0238, or e to the x equals negative 0.238. Is there any number that e to the x could be negative? Isn't it always going to be greater than 0? Doesn't matter what x is. If x is negative, it just flips it. It doesn't make it negative. So this is not possible. This is the one I'm going to solve. So I'm going to take the natural log of both sides, because the natural log of e to the x is just x. Oh, 238. Anyway, so x is equal to natural log of 42.0238, which is 3.74, about. Long way to get there. But the trick to this one, well, there were a couple of tricks. Flipping this, recognizing we've got to get a common denominator, cross multiplying, setting it equal to 0, then recognizing letting u be this so I could turn it into a quadratic, using the quadratic formula, and then substituting at the end back in so we can solve for x. But you can see how this just builds on what we learned in Algebra 2. I mean, you couldn't do this without understanding quadratics, but that was not why, I mean, solving a quadratic was not the point of this problem. That was just a tool to get to the solution. Yeah. Do you want to try one on your own before we turn you loose, or are you ready? You're good?
Yeah.
All right.